Hello. For this problem, we're going to do a lab problem. This is a half Atwood machine, and so to solve this problem, let's take a look at it. So we're going to start with our track, and we have a cart over here on the track, and the cart has a mass of 17 kilograms. Then there's a string with a pulley, and hanging down here is 5.7 kilograms. So that's the mass of the weight. And we're trying to find what is the acceleration. So we're trying to find A. So to solve this, we're going to use F equals ma. And we need to know what force is being applied. The force that's being applied is gravity pulling this down. That is what's pulling this whole thing. And force of gravity is mass times the acceleration of gravity. So this F is going to be equal to the mass times the acceleration of gravity. Okay, so I can plug those numbers in. The mass, I'm only going to use the hanging mass because that is the only mass that's pulling it. And I'm going to use 9.81 for my acceleration of gravity. And if I put that in my calculator, I get a value of 55.92. So that's the left side of my equation. The right side of my equation, I have an M and I have an A. The M is the mass being pulled. The mass being pulled is both M1 and M2, and I can label these M1 and I can label these M2. So actually the mass being pulled is my M2. M2, that's the one that's applying the force. That's the one that's pulling everything. That's the hanging one. But the one that's pulling everything is pulling both. It's moving both masses. So over here, I have to include both masses because that's what's being pulled, is both. So this one is the one that's applying the force, but once again, it's pulling both. Okay, so now when I plug my numbers in, let's close it. Okay, oops. Okay, so I have my two masses. So I would have 17 plus 5.7 A. So this would be 22.7 A. And now I can add 22.7. I'm going to divide both sides by 22.7. And 55.92 divided by 22.7 gives me an acceleration of 2.46 meters per second squared. And so, once again, I'm just using F equals ma, and I'm thinking what force is being applied, and the force that's being applied is caused by this guy. It's caused by gravity pulling that guy. So that is why I have this over here, mass times acceleration of gravity. And then I think about, okay, well, what mass is being pulled? That's this number. And the mass that's being pulled are both of them. And so that's why I end up with this equation here, which is a little different. So this one kind of morphs into the other one. All right, hope you understand that. If not, please ask some questions, and best of luck.